Welcome back. Session will continue with discussion on convolution. So our aim in this session, in few sessions, was to compute the convolution between x and h, but without resorting to this tedious summation formulas. Instead, use linearity and time invariance property of the system. So what we have been doing, we are saying we will apply the first, we'll apply the inputs individually. Then we apply a shifted input. Then we scale the inputs first to check the output. And if we apply the input as once, means we apply these inputs together, and we saw the output will be simply the sum for the individual response. Now, have a look at this. Instead of calling it as sequence, I can call it x of n. So this is x of n now. So what will the output is simply y of n. So you can say the whole response is y of n. This is just a name. So if I say x of n is this, we can say I can break the input like this. I can check it out like. Now I hope you are getting the idea. Let me illustrate it now for any input. Let's suppose I have a system whose impulse response is, let's suppose it's time 1, again very simple impulse response for computation purposes. And now the input to the system is x of n. Now input to the system is x of n, and let's suppose the values of this input are 2, -1, 2. So this is the input and this is the input to the system. So what will be the output? That's the in. So what is the output of this system? Using the procedure above. Now you saw how if this was x of n, how we can resolve this. Now resolve means how do you resolve x of n in terms of delta sequences? How we can resolve x of n in terms of deltas? And the answer of this complete resolution is given in lecture 4. Please go to lecture 4. This will answer that your question. How do you do the resolution of any x of n? Please see lecture 4. All right. So, but if you have followed this procedure here, you will say this I can write directly as this. I can write simply as this. I can write as twice delta n plus 1 minus this component, then minus delta n, then this component plus twice delta n. So this is the meaning of resolution. So this, now what we'll do, we'll know if the input is delta n, the output is h of n. Same way, if the input is twice delta n minus 1, the output should be, so if the input is twice delta n, the output should be minus times h of n. Output should be minus times h of n. Same way, if the input is twice delta n minus 1, if the system is time invariant system, so the output should be twice h of n minus 1. Same way, if the input is twice delta n plus 1, so the output should be twice n plus 1. Now what we are doing, we are applying this as whole as the input to the system. So what should happen to the output? Now what we have done, we have broken down this input into the individual inputs, minus this delta signals. So the output should be simply the sum of these sequences. So our output will be simply the sum of these individual responses. So the output will be simply, you can write the output directly. You can write the output will be simply twice h of n plus 1 minus h of n plus twice h of n. Now obtain h of n plus 1, h of n, and h of n minus 1, and scale these. So first let me write these individually. So what is h of n plus 1? It's twice h of n minus 1. See, h of n is given to me. This means simply the output is scaled by twice, and it is h of n plus 1 means shifting this to the left. So this is the meaning of h of n plus 1. And what we are doing, we are scaling the every sample point by 2. So this is this. So now next is minus h of n. Minus h of n means multiplying every sample point by minus 1. So you can say that every sample point gets multiplied by -1, then twice h of n minus 1 means simply this one is dealing every sample point by 1, and then we are scaling those values. Multiply 0 by 2, that is 0, 2, and 2. So this is the output, and our job is to add this in the response. So this is the response. This is the response. This is the response of the system when the input is this. Same way, this is the response of the system when the input is minus delta n here. Same way, the output is this when the input is this. So this is the output. So now our next job is to add these individual response. Now if I add these, and this will give me y of n. So y of of these individual plus this is twice of n plus 1 plus minus plus minus minus five plus 1. So these and these are given here. Just add these, add the corresponding sample values. So this is n equal to 0. So first let's obtain n equal to 0.2 minus 1 is 1. So the sample point will be 1. Then n equal to 1. N equal to 1 here is 0. You can check it, that 0 here, and it's minus 1 here. So minus 1, 2, it will be again 1. So this is equal to 0. Then n equal to 2, that is again 0 here, it is 0 here, and it's 2 here. So this is 2. So and rest of the samples will be 0. Then n equal to minus 1. When n is equal to minus 1, the value is 2, the value is 0 here, and the value is 0 here. You can show the value is 2. So this is the output of the system when the input is 2 minus 1, 2. Whose impulse response is this? I hope you have got the idea. This is very, very simple illustration. Now here what I'm going to do, I'm going to give you an assignment that you can do. What you have to do, you have to compute the output of the system whose impulse response is 3, 2, 1, minus 2, and this is the impulse response of the system, and the input to the system is h of x of n, and let's suppose x of n is 2, 1, minus 1, and 2, and this is n equal to 0. What is the output of this system? But following this procedure. So following this procedure, so what you will do first, you will break this into the delta sequence. So you can write this in terms of delta sequences like this. You write it on this and have a look. N one, then n two. Have a look. So this now you will apply as an input individually first. Then you will say the response for individual inputs and check the output. So what will be the, so let me write it for you, then you have to only edit. So what's the response for this? If I apply this as is input to the system, so this is twice h of 1. So the corresponding response for delta n is h of n, or delta n minus 1 is minus h of n minus 1. Then this will be twice h of n minus 2. So this is if the system follows time invariance and additivity property of the this linearity. Then what you will do, you will apply this as the combined input. Means if you apply this input together to the system, and this is same as what is this? This is 2, 1, minus 1, and 2. This is the meaning of this, and your job is to compute. So this will give y of n, simply addition of Because if I write minus plus here, it will be minus. So let me write minus. So see what is this equal. So that's your job. So compute the sum. All right, let me end it here. I hope you understood the concept very well. This is the best explanation of convolution. All right, let me end it here.